Good afternoon, scholars. Mr. Spears here with another exciting lesson from the world of science. Today's lesson we're learning about the atom and how it's built and why it's important to this study of science. Let's first talk about the anatomy of the element. What kind of things are inside the atom to make it what it is? The atom has two main features or structures. That is the nucleus. This is the dense spot of matter that's found in the center of the atom. It's dense because protons and neutrons, subatomic particles as we call them, they're compact there. And around the nucleus is an electron cloud. This is a space around the nucleus where electrons, a much smaller subatomic particle, is zinging and flying around the nucleus. I want to show you a little animation of a zinc atom, what it might look like. The comet-looking things would be kind of like electrons. In the middle you can see there we got some red protons and some blue neutrons. And as we can see, there's nothing static about this atom. Everything is moving. But the electrons, they occupy a space. We call it the electron cloud, and of course the neutrons and the protons are there in the middle in the nucleus. So that gives you some concept of what an atom might look like. Here is a chart that you need to memorize. This gives all the properties of, or some of the properties of the subatomic particles, or the particles that make up an atom. There are three particles that you need to memorize. Those are the proton, neutron, and electron. Let's first run through the proton. It has a charge of 1 positive, or positive 1. We're going to see why that positive charge is important here in just a second. Its mass in atomic mass units is 1, and of course it's found in the nucleus. The neutron, as its name implies, neutron is neutral. And neutral means no net charge, or a charge of 0. Now it also has a very similar mass, a mass of 1 AMU, and of course we know that it's found in the nucleus. Now that leads us to the electron, the third and final subatomic particle we're going to discuss in this lesson. It is the smallest of all the subatomic particles, and it has a charge of 1 negative, or negative by 1. And the reason why that's important is we saw in the animation on the previous slide, those electrons are moving, but they kind of stay around the nucleus. And the reason why they stay around the nucleus is because the protons are positive and the electrons are negative, and so there is an attraction that happens between the two of them that keeps them around, and as we learn more in this course, contributes to the chemistry of these atoms. And of course, they're found in that region around the nucleus known as the electron cloud. Here's another slide that just kind of summarizes what we've talked about. If you consider that the proton and the neutron all have a mass of 1, whereas electron has a mass of 0, and the protons and the neutrons all hang out in the nucleus, you can imagine that the vast majority of the atom's mass is located in its nucleus. That's not to say that electrons don't have any mass. They're actually 1/1800th the size of a proton. That comes to about 0.0006 AMUs. For all intents and purposes, we as chemists round that to 0, pretty much saying that the mass of electron really doesn't contribute much to the overall mass of the atom. And so when we want to find the mass in AMUs of an atom, all we really need to do is count the number of protons and neutrons, because they are the ones that actually have the majority of the mass. Now, how is a neutron created? Well, it's theorized that a neutron, being neutral, is a particle that's is created when a proton, being positive, is fused with an electron that's negative. Of course, they cancel each other's charge out, and you get a neutron with a no net charge, or 0 charge. Now, the periodic table, as you can see here, has a lot of useful information. Now, not every periodic table looks the same, but they have pretty much the same pieces of information. This block of for carbon off the periodic table has its name, the name of carbon, how it's spelled. Underneath the name, we've got the atomic number. This is always a whole number, always a smaller whole number. Okay? And the reason why that I say that is because there is another number that's usually in an elements block on the periodic table, and that's a number that has a decimal in it. Okay, so the atomic mass, this would be the average mass of all known atoms of the element. This is because of things called isotopes. We're going to talk more about these in a future lesson. The average mass of all known elements of carbon is 12.011 AMUs. And of course we can see that this is a larger number, but it's not a whole number because it has a decimal in it. And for elements on the periodic table, their atomic mass is always larger than the atomic number and usually includes a decimal. And then lastly, you'll find this in pretty much every periodic table, we have the symbol of each element. And so carbon is a uppercase C. Now pay close attention to the capitalization. It's very important that you get that right, so you're able to communicate to your teacher what you know. Now we can use the symbol of any element on the periodic table. We can use that, and by putting information around the four corners of the symbol, we can convey certain pieces of information. For instance, if there is a number that's written in the upper left corner of a symbol or by a symbol, that is referring to the mass number, Now what is the mass number? Well, it's the sum of the protons and neutrons in that atom. So we can see here, just from this piece of information, this beryllium atom has 9 protons and neutrons added together. Okay? And remember that the protons and neutrons contain the vast majority of the mass, thus the reasoning for the name mass number. Just below that, in the lower left corner around the symbol, is where you might see an atom's or an element's atomic number written. And the atomic number is really the identity of the atom. It tells us what element it is, because no other atoms besides beryllium atoms is going to have an atomic number of 4. And so this is always going to tell us the number of protons. And if we ever wanted to know the number of neutrons, as we can see here, it's a pretty quick calculation to figure that out. If I have between protons and neutrons, if I have 9 total, all I need to do is subtract the atomic number, which is the number of protons, from my mass number, and I can get how many neutrons are in this atom. So I'm going to go ahead and do that real quick. I have a mass number of 9, and I subtract atomic number of 4, and I get 5 neutrons. So this beryllium atom has 4 protons and 5 neutrons, and I get that just from these two numbers right here. Let's go back to this whole notion of the mass number. It is unique to a single atom. Different atoms can have different mass numbers. That is because they can have different number of neutrons. It can be expressed in many different ways. Sometimes you can just write the symbol of the element and then put the mass number in the upper left corner. Here we have a pretty famous atom. That's a carbon-14 atom used in radioactive dating. You can also just write the symbol of an element followed by a dash and then write the mass number beside it. And then lastly, you can just write the name of the element with a dash and the mass number beside it. Again, when we're talking or referring to isotopes, typically you will see mass numbers written this way. We call this isotope notation. So again, more about isotopes in a future lesson. Now, if you are not told in a problem or you don't know what the mass number of an atom is, there's a quick little fix to that. Just simply look on the periodic table for whatever element you're considering and take a look at the element's atomic mass. The element's atomic mass. And whatever that is, let's say for helium, which has an atomic mass of 4.00 and some change, just simply round that to the nearest whole number. 4.00 would round to 4, and of course that would be the mass number for that atom. Another thing I want to come back to is this notion of neutral. Neutral atoms, what does it mean to be neutral? It means that you have no net charge. Now, how do you have no net charge when there are protons inside you that have a positive charge and electrons that have a negative charge? Well, basically, if you're going to be a neutral atom, then the number of your protons has got to equal the number of electrons. That is, for every positive charge, you have to have a negative charge to cancel it out. Okay? So here I have a carbon atom. Now, why do I know this is carbon atom? Because 6 protons, there is only one element that has 6 protons. It's atoms that have 6 protons in its nucleus, and that's a carbon atom. And so here I have a block of carbon from the periodic table, and we can see here the atomic number is 6, and so I must have 6 protons. And so to be a neutral atom of carbon, I have to cancel out that charge of 6 with 6 negative electrons. So if I take 6 minus a negative 6, what do I get? I get 0. So a neutral carbon atom has no net charge because all the electrons are canceling out all of the protons. Here in this table, I want to fill in the missing information. And there's a lot of stuff missing, but I actually can fill in all of the blocks in this table just by the little bit of information that's provided. Let me show you how I do that. Let's take our first row right here. We have we don't know the name, symbol, or the number of subatomic particles, but we do know the atom's mass number, and we know its atomic number. So we saw in the previous slide that the atomic number is always equal to the number of protons. So if I have an atomic number of 5, then I must have 5 protons in this atom. Another thing that I know is that there's only going to be a certain type of atom that has 5 protons, and that is going to be a boron atom. Its atomic number is 5. Remember, this is the smaller whole number for an element in its box on the periodic table. And it has a mass number of 11 and an atomic number of 5. Now, this mass number, if you'll recall, remember, it is the sum of the protons plus the neutrons. Alright, so if I know that I have, between protons and neutrons, I have 11 total, and 5 of those 11 are protons, then how many neutrons do I have? Well, all I need to do is take my mass number, 11, subtract the number of protons, 5, and I get 6 neutrons. So I'm going to write that there in that box. Now, we can assume that this is a neutral atom. In fact, your practice in this lesson, we can assume that all atoms here are neutral. So if the atom is going to be neutral, then we need the number of electrons to equal the number of protons. Okay, this is what neutral means. So if I have 5 protons, it's going to take 5 electrons to cancel each one of those out. Alright, so from my little periodic table box, it's pretty easy to figure out what the symbol of this element is. It's B for boron. And of course, I can look at another periodic table and I can find out that the name of boron is spelled B-O-R-O-N. In our next example, the 2 pieces of information that we're given is the symbol of our atom and the number of neutrons. So let's try to fill in the rest of the information. N is nitrogen. N is nitrogen. So I'm going to go ahead and write nitrogen in here as its name. Next, what I'm going to do is from nitrogen I can remember that the atomic number, the 7 in the corner of this periodic table, always is going to be the same for nitrogen. So I'm going to write 7 here for the atomic number. Now remember that the atomic number equals the number of protons that are in that atom. And so if I have an atomic number of 7, then I also know that my protons must be 7. So 7 protons in this atom. Alright, now I'm going to use the number of protons and the number of neutrons that I'm given, 8. And remember that when these guys are added together, protons plus neutrons, I get the mass number. The mass number. Okay, so 7 and 8 make 15. So the mass number of this nitrogen atom is 15. How many electrons does it have? Well, like I said, we're going to assume that for this activity that we're dealing with neutral atoms. So to be neutral, the number of electrons needs to equal the number of protons. So if I have 7 protons, I need to have 7 electrons. So just from those 2 pieces of information, we were able to fill out the rest of the empty boxes in this row. Lastly, all we know about this atom is that it's a helium atom. That actually tells us quite a bit. If I go to the periodic table, the box for helium gives me some information. Remember, the smaller whole number is the atomic number, so I can write that in. The atomic number is always equal to the number of protons, so I have 2 protons in this atom. I also can assume that this is a neutral atom of helium. So if it's neutral, that means that for every proton that I have that many electrons. So if I have 2 protons, that's 2 electrons. So that makes the atom neutral. The symbol, obviously, is He for helium. And so now that just simply leaves me with a mass number and number of neutrons to fill in. Now, I can't figure out the number of neutrons without a mass number. And unfortunately, I can't know the mass number without knowing the number of neutrons. So it seems like I'm at a roadblock here. But remember, if you ever get into a situation where you don't know the mass number and you don't know the number of neutrons, simply look at the atomic mass for the element, in this case for helium 4.00, and round that to the nearest whole number. Okay? So 4.00 rounded to the nearest whole number, that is simply going to become 4. So we're going to use that as our mass number. Alright, now I have a mass number of 4. Mass number, remember, is the sum of the protons and the neutrons. So if I have a total of 4 and 2 of those are protons, then 4 minus 2 is 2 neutrons. So I'm going to write that here in the box for helium, neutrons. Okay, scholars, now I'm giving you an opportunity to practice a problem on your own. When I tell you to press pause, you'll pause the video and try to fill out this information for aluminum. And when you're finished, you'll press unpause and check your answers. Press pause now.